So in this lesson, we're going to work through a typical series circuit question. But before we get into it, let's recap some of the main points about a series circuit. First of all, the voltage is shared amongst components. So a component could be a bulb, a resistor, anything that is in the actual main circuit itself. The second thing is that the current, which is the flow of electrons, is the same around the whole circuit, so it doesn't change, unlike a parallel circuit. And that the third point is that the total resistance in the circuit is equal to the sum of the individual resistances. So you simply add up the resistances of each component. So you can see, just looking at this circuit, we have three 12-ohm resistors. So the total resistance in this case would be 36. And then finally in blue, the main formula we will be using is V equals IR. Voltage is equal to current times resistance. Let's take a look at the question. So in the circuit, figure 1, the battery of EMF 15 volts. EMF means electromotive force, and it's just another phrase for voltage. A negligible internal resistance is connected in series with 2 lamps and a resistor. The 3 components each have a resistance of 12 ohms. What is the voltage across each lamp? Right, because each component has the same resistance and therefore has the same demand on the voltage available, then the voltage will be shared equally amongst the 3 devices. Okay, so we have a total of 15 volts. So 15 divided by 3 will be 5. Each bulb gets 5 volts, as does the 12 ohm resistor. Secondly, calculate the current through the lamps. Let's write down the formula. V equals IR. And then we need to rearrange this in terms of I. So I is equal to V divided by R. We know that the voltage across each individual lamp is 5 because we've just worked it out in the previous bit. Now the next thing we need to do is work out the total resistance, which is the sum of the individual resistances. So it's 12 plus 12 plus 12 is 36. So therefore we have 5 divided by 36 gives us a current of 0.13888, which to 2 decimal place is 0.14. So please check out my other videos on series and parallel calculations, as well as a combined question where you have a series and parallel circuit at the same time. Just an extra layer of difficulty there. So work through the series videos first, then the parallel, and then look at that combined one.